This is our .h file for our base class for Irish, which will eventually be inherited by student and faculty. So those are the derived classes because a student is an Irish community member, likewise as a faculty is an Irish community member. The first thing we pointed out in the reading is that any private member of the base class that we want to be able to also be implemented in a derived class should be replaced with protected. Now let's say we had another member. I'll say, I'm just going to call this private. I'm going to call this unsigned int no derive. If I wanted to do something like this, I could put it in the constructor here, but it would not be able to be accessed by derived classes. So let's get rid of this. So everything in Irish can now be in the derived class. We have our constructor for Irish as we have normally. In the rules that I've discussed in the reading, we want to have a virtual destructor in the base class. And the virtual keyword is where we start implementing polymorphism. And we'll see another example of this in a moment. This allows us to be able to ensure that we destruct and clean out from the data heap all the memory that's allocated from the base class, as well as anything else that's eventually allocated by the derived class. Both student and faculty will have their own version of print information. Therefore, instead of having to implement different versions or call it with a different name, we can just call this virtual void, and then any derived class from base class Irish can implement their own version of print information. And then we have our own friend operator here. If we go to the .cpp file, what we're going to see for both the destructor and print information is that they do not have the virtual keyword. So we start here, we see we have our normal constructor, and then we have the destructor here, no virtual keyword. And in this case, we don't have a pointer that has allocated memory in our private members. We don't have any pointers here. So therefore, we normally wouldn't need a destructor, but we just need this in order to meet inheritance and polymorphism rules. Therefore, in order to make this work, basically all we need to do is make it empty. And in this case, to show you how it's working on the stack and the heap, I'm just going to print out the base address of the class. When we get into inheritance and I'm using student and faculty, I'm going to do the same thing so you can see what the computing device is actually doing. Also, we don't need to meet the rule of 3 unless we have a pointer that is a private member. In set home address, this is a conventional set method, and the operator, we have our normal person is the name, so we can just access the private members with .first name, and that's always going to be the case. You'll be able to access all of the elements that way. For print information, for now, all we need to do is just call the private members like so, as we've been doing all semester. What we're going to see later on when we look at student and faculty is we actually have to access private members and methods differently when we compare the base class and the derived classes. In Irish test.cpp, I create 2 Irish objects, then I set the home address, and then I use the overloaded operator to print the results. So I'm going to run make Irish test. We see it's going to compile, and we create 2 objects here on the heap. I print them out, and just like before, we notice that it deallocates in the opposite order. And so that's how the base class works.